Hey folks, how's it going? It is Rob, and I'm coming to you here with a video uh, discussing Math 115 Midterm Examination 1. And in this video, I'm going to be walking through the problems and explaining the ideas and how to solve them. I just want to note, if you took, for whatever reason, one of the makeup exams due to an extenuating circumstance, this midterm the solutions are not going to be the same. However, the gist of it is going to be the same. So by watching me do these problems, you're going to get a sense of how you would do them if you were going to do them for your particular numbers. And you'll see more kind of as I go through it. All right. So again, the goal is to kind of go through this kind of so far from what I've seen in the grading, kind of state some things that I've noticed and also some things to be aware of as well. All right, so just as a quick background, this exam covers stuff like equations, right? We talked about literal equations. We talked about inequalities, simple and compound inequalities. We talked about absolute value equations and inequalities. We talked about slope and the three forms of a line. We talked about whether things are functions or not in terms of inputs and outputs. And then we also did some things related to various functions, being able to evaluate them, graph them, and kind of state some important features. Towards the end, we started to talk about systems of equations, and later in the lesson, we talked about how to solve them algebraically. Since it was something that we just covered like right at the end of class, I thought it wouldn't really be fair to make it be something that you definitely had to do for points. And so for that reason, it was a bonus question. In general, my feeling is for many individuals, this was definitely one where time was of the essence. So I think that in the end, it was probably good that the bonus was a bonus, because I think it was already a lot to take in as it is. All right. So all right. So the first one I'm going to start with, right, is solving equations. Now this was right at the beginning of class, one of the first days of class, in the first weeks. We talked about how to solve equations. Okay. And remember, what we're going to essentially be doing here is getting x alone. Now, you can see I kind of dispensed with the kind of more straightforward equations, right? And that was to give you less and have you do more with it. So if we look at this equation right here, all right, one thing we want to do, and I think this might have been difficult for a couple people, just making sure you're rewriting this accurately, okay? Now I'm going to go ahead, and there's two different ways you can solve it. You can either move the 8 over, right? I would actually prefer to add than to subtract. So I'm going to add 8x to both sides, and I'm going to add 53 to both sides. Okay? And when I do this, I get 48 equals 12x. Okay? And so what I get when I divide both sides by 12 is I get that x is equal to 4. All right? Now you can see if you did it the other way around, you would have gotten actually negative 12x is equal to negative 48. Same exact answer. All right. One thing I did maybe knock a couple of people for is, please don't forget you do need to check your answer. I'm not going to show you doing it in this video just for time's sake, but what you would be doing is you'd be taking the 4 and you do want to plug it back in. So I did make it worth points, but at the same time, if you plug the number back in and get both sides equal to each other, then you leave the test knowing you got that question right. And I'll be honest, this was one of the best questions overall that in terms of what I saw so far with the grading. All right. And I'll talk about one little thing when we get to part C. So in part B, right, the big idea is you do need to do the distribution and the combination of like terms, right? So I did want to add that element in there of also assessing your ability to distribute and combine like terms. The big thing that I saw, one thing is just please remember, and one thing that I didn't see, sorry, I got some notifications there. Sorry about that. So one thing I did see was some not distributing fully to everything. And so you just want to really make sure you draw those symbols in there if it helps you make sure, right? Because that could lead to some issues. So I get 3x minus 21 equals 5x plus 5. Okay, you just want to make sure you combine like terms, and then it's just an equation with variables on both sides. So negative 20, I could do this for example, right? Where I'm subtracting the 5 and I'm subtracting the 3x rather, and that ends up being x is equal to negative 13. Okay, that's something you could also check, and I believe you get something like negative 60 on both sides, something like that. Okay, last one I'm going to do is C. So this is the one that kind of threw a couple people off. So on the left, everything's hunky-dory, right? Nothing to really do there. On the right, let's go ahead and distribute, and I get 3x plus 15 plus x. Okay, and when I clean that up, what I get is 4x plus 15. Okay? But notice how that simplifies to 0 equals 0. So you just want to make sure when you get something like that, that's okay. That means that all real numbers are solutions to these equations, okay? Or infinite solutions is fine, okay? Because what that means is that no matter what you make x, right, everything's going to cancel out on both sides in the end. So all that matters is what's left. And since what's left is a true statement, what that means is no matter what you plug in for x, you're all good. I believe in the book we talked about this being called an identity. Okay, so some things I also saw was no solutions or x equals 0. No solutions is not true because these things are equal to each other. And x is 0, I guess, is a solution, but it's not really all of them. All right, and in part C, if you don't plug in, I was obviously a little bit more lenient because, right, how could you check possibly all real numbers? All right. So, of course, if you have any questions, feel free to go back and rewind. And then I'm going to go ahead and move on to question 2. All right, so in question 2, you just want to isolate the variables. I think for the most part, A went pretty smoothly for people. So, look, you want to isolate M. All you need to do is divide both sides by c squared. Okay, I saw some people taking square roots. That's not necessary, and the reason it's not necessary is because you're not isolating c. Right? Taking a square root is not going to do anything in terms of helping to get m on one side of the equation and everything else on the other side. And in fact, it probably gets you further from the answer. Okay? So that one might have been deceptively straightforward. In terms of the other one, so for x, what you want to do here, and this is a really important skill when we get to pre-calculus as well, and we need to start doing inverse functions, is you want to get the stuff with x's on both sides. I really just thought of this as I was kind of looking at this right now. It's really, really helpful and something that some pre-calculus students will struggle with. Okay, so you collect the x's on both sides, and the stuff without x, you put that on the other side, right? And remember, that's because you want to get x alone. Okay, so it helps if you can get x on the same side. All right, and then one thing we need to see is that if you look at it, we talked about taking that common thing out there. So we take out the x and then m, because you can imagine distributing and getting mx. Then you can imagine distributing c and getting cx. Okay, and the last step is just to divide by m plus c, and you get h plus 5 over m plus c, okay, is equal to x. Now, I know there's a variety of different answers I got in here. I think the number one thing that was a little bit of a challenge for people was getting that x alone. But if you think about it, if you got an equation where you still have x's on both sides, that's like a sign that x is not alone, so you're not quite done yet. And it's okay if this is something you're struggling with, because we are going to see more examples of how you solve equations like this as we proceed with the course. All right, so that's how we do number 2. Feel free to rewind and go through that if you'd like. I'm going to move on to number 3. So number 3, we need to solve the linear inequalities. So the one thing that I noticed here, I think overall people did okay with the content. I think the number one thing we just need to be careful with is the 3 ways to represent it. I think a lot of reasons points were lost in this case, at least from what I've seen so far, is having to do with one or more of these missing. So I would really recommend you check out my feedback, because I did do feedback for each grade, so you can see where those points were lost and kind of things to think about for next time. Because I do want to remind you, this stuff could come up at that final exam at the end of the semester. So I'm going to take a look at this one first. Okay, so what I really love to see people doing is rewriting. That's a really good strategy. Put everything out there. And you kind of had to at the same time because it was on the computer if you didn't print it. All right. So minus 3s, because I'm going to add the 4. Okay, and this one ends up actually becoming kind of funky. Okay, and I might have planned for that 4. Maybe I thought that 14 and I was trying to get it to be a 15. But either way, that's okay. It's a fraction, nothing to worry about. So the 3 ways, the verbal notation, s is less than negative 14 thirds. That's what verbal notation means. If you were to say this out loud, what are the words you would say? You'd say s is less than negative 14 thirds. That's all you're doing. Okay, set builder notation. So you write s, because that's the letter, such that s, and then you just write your answer over again. Okay, and then interval notation would be negative infinity, comma, negative 14 thirds. Okay. All right. So again, things to think about. Biggest thing, remembering you might have been asking, hey, why did you change the direction there? Well, just remember that when you divide by a negative, you need to flip the sign. The direction has to turn. Okay, so instead of being greater, it's going to be less. Okay. All right. On the second one, let's take a look. So this is what we call an and inequality. So we saw and inequalities written 2 ways, with the word and between them, which is the not really way most people do it. The more common way people do it is like this. Okay, so what we're gonna do is, remember, we're gonna do the same thing to part 1, 2, and 3, and the goal is, remember, to get p by itself. So we're gonna focus here. We're gonna think about, if I was gonna get p alone, what would I do? And so the first thing I would have to do would be to add 16. Okay, and the number one thing people sometimes get confused about, and that you have to remember, is that when you do something to one part of an and inequality, you do need to do it to all 3 parts. So remember, the two big misconceptions: one, looking here, so maybe adding 4, right? So you're not looking where p is, and the other thing is involving things you need to get p alone, forgetting to do it to all 3 pieces. So here you would get 12. Okay, here the 16s would cancel, and here you would get 54. So when you divide by 3, you get 4 is less than or equal to p, which is less than 18. So let's take another look. 12 is less than or equal to 3p, is less than or equal to 54. Okay, and I do a lot of this work in my head, to be honest with you, but it's okay. You have a calculator to use, so it shouldn't be a huge deal, right? And then you divide by 3. 12 divided by 3 is 4, etc. So how you'd write this, now keep in mind, this is the interval. So 418, parenthesis, because it's not or equal, bracket for the other because it is. So s is greater than or equal to 4 and less than 18. That's the verbal. And the set builder notation is the p's, and I guess, sorry, we should use p instead of s. The p's such that 4 is less than or equal to p, and p is less than or equal to 18. Or p is less than 18. Okay, it's the second one. All right, third one was the trickiest, and one of the things I did see is that somehow I think one of the pieces got lost. So remember, with an or inequality, if it starts an or, there needs to be an or in the answer. That's really important. So here I'm going to isolate them individually. So the first thing I'm going to do is focus here, and that would be by adding 5. So 4q is greater than 16. So q is greater than 4. And then over here, I'm going to get negative 2q is greater than or equal to 18. 18. So q is less than or equal to negative 9. But because there's an or, I think the one thing we're forgetting is to put that or in the end. Okay? Make that a q. So that is the So what we do, here's how I write it. So we're going to do the variable q is greater than 4 or less than or equal to -9. Okay, the set notation. Okay, now we were using q's here. So q such that q is greater than 4 or q is less than or equal to -9. Okay, and then finally the interval notation. Okay, negative infinity to -9, that gets this piece. Then the u, and then 4 to infinity. Okay, so again, we start one at a time. We isolate, so we add the 5 to get 16 and divide out to get 4. Here we subtract to get 18, dividing, remembering that the negative is going to flip the direction. Now remember that big step of bringing the or back so we get both of these pieces. It's extremely important. And then the way that we kind of close it off with the 3 representations. So again, if you need to rewind, feel free to do so. And then in a second or two, I'm going to move on to the next one. All right, this was a really difficult one for many of us, folks. So yeah, some of us, we really got to work on the absolute value. Really, really important. I can give you a really high level of certainty. You're going to see this later in the semester, if you know what I mean. So the trick here, remember, this goes bars alone. Okay, so number one thing people did not do that was crucial, and that was a big thing I warned you about, was you didn't get the bars alone. So the first thing you should be doing is getting the bars alone by subtracting 3. Then ask yourself now, what could I have p minus 3 be? So either p minus 3 is 2, because the absolute value of 2 is 2, or p minus 3 is -2. So see, once you get the bars alone, then all you just worry about is how to get what's in these bars to be whatever's on the right-hand side of the equation, or the opposite. So here we go. So that means p is either equal to 5 or p is equal to 1. Now, here's how you write this. Other thing that I think we need to work on, you write it as a set. Do not write it as a point. Too many people wrote it like this. This is what we can't be doing. Okay, this is an interval. This means all of the numbers from 1 to 5. Or it's a point referring to 2 variables. If it's an interval, that's not right, because not all the numbers make it work. Only the numbers 1 and 5 themselves make this work. So that's not true if it's interval. And if it's a point, it's referring to a whole nother variable, and that variable is not in play. So it's not really the appropriate thing to do here. Please use a set, because the set says 1 is a solution and also 5 is a solution. Okay? So hopefully that helps. Next one, similar, you do want to get the bars alone. So just remember, the way you get the bars alone are just like the way you get any other variable alone. Okay, one thing I think some of us need to work on, remember, this is not something that's being added, it's being multiplied. So you do not want to subtract by 2. You do want to actually divide by 2. I did see a couple people turn this into an 8 by subtracting rather than dividing. That's a really, really important fundamental of solving equations. You don't want to forget about that. So if m plus 4 equals 5, either m plus 4 is equal to 5, or if it's absolute value at least, because right, the absolute value of 5 is 5. But if m plus 4 was equal to -5 when you took its absolute value, you'd also get 5. Okay, so for it to be equal to 5, m has to be 1, and in this case, -9. So you'd write this as -9, preferably put them in order, -9, 1. If you didn't have this in order, that was not something I would have marked you down for, but it is the correct thing to do ideally is to put it in order. All right, last one really threw a lot of people for a loop. So the bars alone, it basically works the same way. So you got the n plus, so the first thing I'm going to do is either divide by 1/2 or multiply by 2. It doesn't really matter what I do here. So a lot of people had problems interpreting where it goes from here. So remember, absolute value inequalities play out one of 3 ways. In this case, because I'm less than a positive number, right? Think about what numbers have an absolute value that's less than 20, right? 19, 18, 17, 16, 15, those positives, but also negative 19, negative 18, negative 17. So it's all the numbers in between negative 20 and positive 20. So remember, what you want to do, one way you can do it is you can split it, because in this case it's facing away from the bars. So in this case it is appropriate to split it, and actually you can do this into an and inequality. Okay, now this is not obvious, but it was something that we did cover in there, so it is something you might want to recap if this one was something that was confusing to you. So that would be negative 20.5 is less than n, which is less than 19.5. Okay, or you could have written it negative 20.5 comma 19.5. So this is a case where it is appropriate to write it like that, because now you're saying anything between negative 20.5 and positive 19.5 will make this true, and that actually is a true statement, and we've actually shown that. Okay, so I'm going to say this for a lot of people. I did say this explicitly in the feedback. I really recommend you definitely take a look at absolute value equations and inequalities, particularly the inequalities, because again, I really would count on them to come up later in the semester. All right, so the next thing I'm going to talk about is this one. This one, again, there's going to be some things to discuss. So everyone was very, very on point in terms of first finding the slope. All right, I think there was actually a lot of agreement on the slope. So remember, the rise is, and a lot of people, excellent job on your note sheet. Okay, a lot of people with really organized note sheets had this on there. Okay, and then this. So you end up, and that should be a 5, not a 6. Okay, so you end up with a slope of 2. Okay, now that slope of 2 is what you're going to use for your point slope and your slope intercept. So, right, the idea was this was something you probably wanted to put on your note sheet, right? Because it's not something I would have asked you to memorize, right? And I think I might have said in class, right, guys, this is something you want to put on your note sheet because I'm not going to ask you to memorize this stuff. So for point slope, there was 2 ways you could have written it. Either y minus 13 equals 2 times x minus 3. The other way is y minus 3 equals 2 times x minus negative 2. I guess there was a third way, y minus 3 equals 2 times x plus 2, right? These are equivalent to one another. But really, and as someone pointed out, right, if you were to do distribution, what you would see actually is that you can easily put it into slope intercept form from point slope form. If you did this completely correct, you'd be marked full credit. You don't have to actually derive it. So for example, the other way to find slope intercept is by saying, okay, so I'm going to use this combo. So when y is 13, right, we know that m is 2 and x has to be 3, right? So in order for this point to be on the line, when I plug in 3 for x and 13 for y, both sides need to be equal, right? That's the definition of a solution. So that means for this to be true, b has to be equal to 7. And then you come over and write 2x plus 7. So there's multiple ways you could have gotten it, but it was really cool to see the ingenuity, right, with regard to people being able to convert from point slope to slope intercept. Very creative, a lot of ingenuity, and that's completely mathematically acceptable. All right. So again, please make sure you understand the 3 forms. Again, there was a lot of variability you were allowed given the 2 points. These are actually equivalent. For example, again, if I was to distribute y minus 3 equals 2x plus 4, you can see I can add, and I get 2x plus 7. So it again shows you they're equivalent. Okay, so there is some variability, but this is something you really want to lock down if it's a place you're struggling. It'll be helpful now and in the future, especially calculus if you go to calculus. Okay. So this one was functions and relations, not much to this one. The big thing that I kind of predicted would be a struggle is remembering what's going on with your inputs and your outputs. So the first one's pretty straightforward. It is a function. Every input only appears once. And if every input only appears one time, you don't have to do much more than that. Because remember, the key aspect is every input has exactly one output. So if there's only one of each input, there's nothing that would be challenging that. Now, where I got people successfully for some people, the gotcha was kind of number B. All right, and you can see that 410 is actually repeated twice. Or rather once, I suppose. So it's repeated, but look, that's actually okay because that input still has one output. Now, some people were very astute with respect to, they drew a little diagram here, a little cloud diagram. And now you don't repeat the 4 because you already have the 4. Okay, so you'd connect 2 to 5, negative 2 to 5, 4 to 10, 6 to 8, 9 to 12, 10 to 16. Oh, wait, 4 to 10. I already have that. Perfect. So one connection each. You don't duplicate them. So that one's okay. The issue, as many people identify, is with C because you have 2, -1, and 2, 0. And that's all you have to say. A lot of people very nicely said it's not a function. 2 has 2 different outputs. Perfect. All right. Last one is number 7. So the big thing was, and maybe it was a time thing, a lot of these were left incomplete. So the key here is that there is some structure you can make use of that will help you here. So for example, if I'm thinking about letter A, right? Let's start with A. I'm not going to really go into the graphs because I think that you can do them, but I'll talk about that in a second. So I start with -5. I plug in -5. I get -10 minus 3, which is -13. So I should back that up. So -5, -13. But if you notice, if you remember that the slope is 2, then you know when you go to -4, you're going to be at -11. When you go to -3, you're going to be at -9. 2, you're going to be at -7. 1, -1, you're going to be at -5. 0 is -3, which we know that's the intercept. 1 is -1. 2 is 1. 3 is 3. 4 is 5. 5 is 7. Okay. So the one big opportunity that was lost here is that a lot of people went and made a graph and they didn't really include any of these actual points. They just guesstimated the graph. And I think especially if you did all this work to plug in, you really kind of sold yourself short because those were all points that you could use for reference points to really improve the accuracy of the graph. Okay, so more or less though, you should see a graph that looks something like this. So you have an intercept at -3. I'm not going to really practice what I preach. It's a lot more difficult, especially if I want to stay timely here to get that done. But I did want to highlight that as a potential opportunity. For the domain, I was looking for a complete domain, -infinity to infinity on both ends. That is important, as well as the range. Okay, you're going to see a similar thing with the x plus 2. So you're going to see, so the next one, I'm just going to erase this graph. All right, the next one, you plug in -5, you get 5, so that's 7. Plug in 4, you get 6, 5, 4, 3, 2, 3, 4, 5, 6, 7. So this one, you get this nice pattern. Okay, and many of us were able to, this is D1 and R, many of us were able to identify the domain as -infinity to infinity and the range as 2 to infinity with a bracket on the 2. Very good. Last one was a quadratic, so you were just squaring it. So 25, that would be 27. 18, 11, 6, 3, 2, 3, 6, 11, 18. So again, you get that nice pattern. Now I know this one would have been hard to use more points, but I did see some graphs that were pretty clearly kind of guesstimates. And again, you're kind of selling yourself short, because especially with respect to the quadratic, look, I get you see that explosive growth, but if you think about it, you got 0, 2, you got like at least, let's see, maybe 11 would be a stretch, but you got 1, 2, 3, you got, look, you got negative 2, 6, negative 1, 3, 0, 2, so you got 5 solid points that fit on the graph, right? 1, 3, and 2, 6. So think about that, right? You're selling yourself short. You're doing all this hard work, and often great work, but if you don't use it for the graph, that kind of does defeat the point. My idea was to have this feed into each other, okay? So again, the last one, the domain, and the domain in this one actually ends up being the same, and as with the range. All right, folks, so last one I'm going to go into is the bonus. So on the bonus, you need to solve by graphing. Maybe by now you could see these would actually be wicked easy to solve with elimination or substitution, but we're going to go in with graphing anyway. So my recommendation would be, you want to think about, one way to do it is to write it in terms of slope-intercept form. Now you do have to get it right, and if you don't get it right, that's where you mess things up. But here's another way to do it. Let's look at the intercepts. So if x is 0 and y is 5, that's a point that's got to be on the line. Now, I'm not going to get an exact number, so I'm going to find just any other random point. So what if x was 2? If x was 2, this would be 4. So y would have to be equal to 1. Okay? The 2, 1 is just a random point, and there's many other points you could use as anchor points there. I just need a point for quick reference, because I need to have 2 points to be able to connect them to make a line, right? And so in order to do that, I just had to find another pair of x and y that made the equation true. Now I'm going to look at the other one. So we have a similar issue here. So first, I'm going to look at if x was 0, and if x was 0, y would have to be negative 3. And I'm going to have a similar issue. So I'm going to say, so here it was 2, 1. Here I'm going to say x is 1. 2 minus what is 3? Negative 1. So 1, negative 1. And I'm going to connect them. I think I've got my intersection point here. All right, let's just make the sign a little thicker. Put arrows on the ends. And I believe I have an intersection at 2, 1. So you do need to actually identify the intersection point. And if you actually check 2, 1, 4 plus 1, we already actually identified that. And on the other one, 4 minus 1 is 3. So 2, 1 is the solution to that system. The other one was a little bit more challenging. Here you might want to actually take advantage of being able to convert to slope-intercept form on this one. This one, we're going to take the other strategy. So here I've got 5x plus 6. So 1, 2, 3, 4. So this is an example of one that would be easier to solve with substitution, because you could just easily isolate the y, or you could double the equation and add through, and you'd find some help there as well. So here I'm going to be going up 5 over 1, but since I can't fit that, I'm going to go down and left. All right, I get my 2 points. I connect them with a line. Everything appears, at least for now, to be good. All right, let me just get make this darker, put the arrows in the end. Perfect. The other one I am going to do intercepts. So if x is 0, y is going to be 6. Oh, and it looks like I actually just found the intersection point, but I should graph out the rest of the line. And if y is 0, x is going to be negative 3. So this one does have 2 nice, clean intercepts. You can see again, 0, 6 is the solution to that, as we proved. All right, so folks, that basically wraps up the exam. I hope that you were able to find this video helpful, and that it provided you with some hopefully some answers to some of your questions. For those of you, again, who took the midterm, In a makeup midterm, you're going to notice that these answers are similar to yours, but obviously they're going to be a little bit different, though they did preserve essentially the same level of difficulty. So if you have any questions, I encourage you to email me. I encourage you to look out for any potential drop-in hours. But folks, keep it up. Just take a positive mindset as we go forward. I'm looking forward to our next exam. And remember, you can do it. All right, until next time, have a wonderful day.